Have you ever wondered what it would feel like to actually fly around the moon? I mean, really, truly be out there, further than any human has ever gone before? Well, buckle up because Artemis II just made history, and it is going to completely change how we think about the future of space exploration. And no, this is not science fiction. This is happening right now. For the first time in over 50 years, humans have journeyed back to the lunar vicinity. For brave astronauts just returned from a 10-day journey around the far side of the moon. They set a record for the furthest humans have ever traveled into deep space. Just think about that for a second. Millions of miles away from home, looking back at our tiny blue planet. It is mind-blowing. But why does this matter so much? Because this is the final proof of concept before the Artemis III crewed lunar landing. We are not just visiting anymore. We are preparing to stay. And the technology making this possible is absolutely insane. Let us talk about the space economy. It is not just about rockets anymore. Have you heard of space-based computing? Companies are literally exploring the use of orbital data centers. Imagine training artificial intelligence models in space, taking advantage of the naturally freezing temperatures to keep servers cool. Sounds crazy, but it is a multi-billion-dollar industry in the making. This mission proves our life support systems, navigation and deep space communication arrays work flawlessly. But getting there was no easy feat. The engineering required to build the Orion spacecraft is a marvel. Millions of lines of code, thousands of sensors, and a heat shield designed to withstand temperatures hotter than the surface of the sun when re-entering Earth's atmosphere at 25,000 miles per hour. And what about the astronauts? They experienced the overview effect, a cognitive shift in awareness reported by some astronauts during spaceflight. Seeing the Earth from orbit, a fragile ball of life hanging in the void, changes a person. It brings a new perspective on our petty squabbles down here. So what is next? Artemis III is aiming for a lunar surface landing. We are going to see the first woman and the first person of color walk on the moon. And this time we are bringing sustainable infrastructure. We are talking about lunar habitats, rovers, and maybe even extracting resources from the lunar soil. But let us dig deeper into the actual hardware and what it takes to survive in deep space. The spacesuit itself is practically a miniature spacecraft. Each suit costs tens of millions of dollars to develop and is equipped with advanced life support, temperature regulation, and high-definition communication devices. They have to protect astronauts from extreme radiation and micrometeoroids traveling at thousands of miles per hour. It is a masterpiece of modern engineering. Now, think about the propulsion systems. The Space Launch System, or SLS, is the most powerful rocket ever built. It generates 8.8 million pounds of thrust at liftoff. That is 15% more thrust than the mighty Saturn V that took the Apollo astronauts to the moon. When that rocket ignites, the sheer power shakes the ground for miles around. It is a true spectacle of human achievement. Beyond the rockets and the suits, there is the gateway. NASA is planning to build a space station in orbit around the moon. This lunar outpost will serve as a staging point for deep space exploration. Astronauts will dock there, transfer to a lunar lander, and descend to the surface. It will also be a laboratory for cutting-edge science experiments that simply cannot be done on Earth. And the implications for everyday life on Earth are massive. The technologies developed for these missions often find their way into consumer products. From water purification systems and advanced materials to medical imaging and telecommunications, the spin-off technologies from space exploration benefit everyone. The investment in space is an investment in our future. Looking even further ahead, the moon is just a stepping stone. The ultimate goal is Mars. By establishing a sustainable presence on the moon, we are learning how to live and work on another world. We are testing the systems and operations that will be necessary for a crewed mission to the Red Planet. The challenges are enormous. A journey to Mars takes months, and the communication delay can be up to 20 minutes each way. But the Artemis missions are paving the way. The private sector is also playing a huge role. Companies like SpaceX, Blue Origin, and countless startups are driving innovation and driving down costs. This public-private partnership model is revolutionizing the aerospace industry. It is creating jobs, inspiring a new generation of engineers and scientists, and opening up access to space like never before. What is particularly fascinating is the prospect of lunar mining. The moon's south pole is believed to hold vast reserves of water ice in permanently shadowed craters. This ice is not just for drinking. It can be broken down into hydrogen and oxygen to create rocket fuel. This means the moon could become a deep space refueling station, drastically reducing the cost and complexity of traveling to Mars and the outer solar system. Furthermore, Helium-3, an isotope rare on Earth but abundant on the Moon, could potentially fuel future nuclear fusion reactors, providing a clean and virtually limitless source of energy for humanity. The economic and strategic value of the Moon is becoming clearer every day. It is the new gold rush, and the stakes have never been higher. We are standing on